Dear student, today I am going to explain about Kirchhoff voltage law and loop law, also name given this. Kirchhoff voltage law and loop law, and that also known as KVL, KVL, KVL. Now, actually this law is based on the conservation of energy only. First, we write down the definition of the KVL. The algebraic sum of the algebraic sum of all the voltage in a closed loop closed in a closed loop will always be equal to 0 means what? The algebraic sum of all the voltage, algebraic sum means with sign also. Algebraic sum of all the voltage in a closed loop will always be equal to 0. Means summation of V become 0 in a circuit, in a closed path, a closed loop. Next point right now, it is based on law of conservation of charge, based on the law of conservation of charge, conservation of energy, law of conservation of energy. KCL is the based on the law of conservation of charge, but KVL based on law of conservation of energy. Law of conservation of energy. For example, the simple electrical circuit having load resistance R and connected with the battery cell having EMF E and internal resistance R, EMF E. Look at this. In this circuit, external resistance and the internal resistance both are the only consume the energy, and only cell having energy. So only cell is supplier of energy, and load and internal resistance both are consumer of energy. This consume the energy. For example, like this, suppose in this circuit current direction is like this. Current will flow like this, and everyone know what is the value of current is here. What current is equal to E by R plus R. This already know, but according to the KVL, algebraic sum of all the voltage in a closed loop will always be 0. For example, like this, I am taking my loop direction like this. That is loop direction I am taking here. This loop direction is what? It's clockwise, and current in the loop also clockwise. If current, look at this, if current in the closed loop, in the circuit, if current direction is what? Clockwise, and loop direction also clockwise, then means what? Loop direction, whatever loop direction you can assume yourself also. Loop direction you can assume clockwise or anti-clockwise. But loop direction similar to the direction of current, same direction of current, means in the current also in closed circuit is clockwise only, current is also in clockwise, and loop I am assuming what, loop also in clockwise, loop direction is also clockwise. If my both the direction is same, then resistor is consumer of energy, means if direction is same means across resistor potential drop delta V become minus I into R, that negative only. Potential drop become negative. Across resistor drop in the potential become negative. And second point, when current leaving the positive terminal of the battery, this is the case of when both are same, when the direction of current, loop direction and current direction both are in same, either clockwise or anti-clockwise in the loop, then we can say that what, across resistor potential drop become negative. And next thing is what, when the current leaving the positive terminal of the battery, then across battery voltage drop able to get positive plus E. This is valid for which case? When current direction and this follow, this when the loop direction and current direction both are similar, either clockwise or anti-clockwise, then delta V voltage across the resistor be able to get negative, and voltage when the current leaving the positive terminal of the battery in the circuit, then battery voltage, battery EMF able to get positive. The same things what happen in the circuit, same circuit, when the current entering the positive terminal of the battery, then potential, suppose this cell EMF is this, then potential drop able to write what, minus E. This rule if you follow, then each and every question of KVL able to solve very without any mistake. Look at this. When the loop direction and same as the direction of current, means in this circuit loop direction is what, clockwise, clockwise, and current direction also clockwise, means both are same, then resistor, across the resistor voltage drop able to get negative IR. Okay, any resistor for internal resistance also able to get only I into smaller. Then EMF when the current leaving from positive terminal of this battery, then voltage across the battery able to get what, plus only. And when the current entering the battery, positive terminal of the battery, then able to get delta V negative across the battery. Now by using these things, now I am writing the equation of this. Can erase this part now? Okay. Just stop with these things, then I will start now. Okay. Then I am going to erase this part. Now, 1 minute. Again, I am drawing this simple circuit like this. Simple electrical circuit having cell having EMF E and internal resistance small r, and this is the r. Look at this. Current in the circuit direction is this only, is the current. I already calculated this ER plus small r. Now I am assuming what loop direction this. I am assuming what loop direction is like this. I am assuming loop direction like this. This is the loop direction, loop. Then this case, I already said what, there are two things. First what, case number first, when loop direction, when loop direction same as current direction. Current direction means in this case loop direction is what, clockwise, and current direction also clockwise, means both are same. Then delta B, when the current this voltage across resistor, voltage drop, then voltage drop across resistor is equal to negative, means I into R is negative. Okay. Now and second case already explained to you what, when this case when the current entering leaving the positive terminal of the battery, then delta V become here plus E. The same things here, when current entering this positive terminal of this battery, then delta V equal to minus E. If these three things remember, then able to solve the problem of this. Look at this. Now I am going to apply here. Look at this. When the this is the positive terminal of this battery, positive terminal, this is the negative terminal. This is the positive terminal, this is the negative, and current leaving this. Then I am going to start from this. Then I am writing what, plus E. Now current and loop direction current both are similar, clockwise. Then resistor across the voltage drop able to get negative, and that value is nothing but I into R. Now the same current enter this resistor also, then again able to get what, I minus R. I already explained to you what, when loop direction clockwise similar as the current direction in the circuit, closed circuit, then voltage across the resistor able to get negative only, that is I into R. And the current leaving the positive terminal of the battery, that will take positive. When the current enter the negative terminal of the positive terminal of the battery, then able to take delta B is negative. By using this law, these things we are able to solve this, then able to get what, I is equal to E R plus R. This also able to get here. Okay. Then able to get current here also is this only. Then these things very important to know how, when the current direction and loop direction both are same, the resistor behave like consumer of energy, and when the current leaving from positive terminal of the battery, then the battery is what, supplier of energy. That's why using plus E. When the current entering the positive terminal of this battery, and that battery is known as what, charging condition, means this battery is the consumer of energy, because this consume energy because it's a charging condition, and this is what, discharging condition. Okay. Now the second part, what, case number 2. Case number 2, I am going to erase this part. When loop direction, when loop direction when direction of loop is clockwise means, and current is what? Anti-clockwise. Direction of current anti-clockwise means counterclockwise. Counterclockwise means here the direction of loop is different and direction of current is different. Okay, I am writing here what loop I am changing here. Loop direction is what I am using, counterclockwise and here clockwise. Why? Because in this circuit already current is flowing in clockwise. Now I am going to change the loop direction here. Now I am going to change the loop direction. Why? You can able to loop direction able to make yourself also. I am going to make this loop direction is like this. This loop direction is what? Counterclockwise. Counterclockwise. Now look at this. Now what happened? When the direction of the loop and direction of the current both are anti-parallel, means both are opposite direction, then voltage across the resistor, then voltage across the resistor, delta V, voltage across voltage drop across resistor become plus IR, positive only, positive. Okay, then voltage drop become positive, and delta V, when the current leaving from this battery like this, positive, and loop direction is opposite to this, then delta V become what? Minus E. Okay, here what happened? When the positive negative, that battery become what? Is consumer of energy. When the current coming from positive terminal of the battery and your loop direction is what? Opposite to the current direction, then delta V able to get negative. The second case what? When the battery current entering this battery, then delta V able to get what? Here positive. The opposite of the previous. Then now I am going to apply here. Look at this. I am starting here. This is the my clockwise, this direction of the loop like this. Then this current leaving from positive terminal of this battery and loop direction opposite to the current direction. Then I am writing here what? Minus E. I am starting with minus E because delta V become negative. Now this resistor current is what? Opposite to the loop, then able to get what? Plus I into R. Then again current opposite to the resistor this, then we can write what? Plus I into R equal to 0. Then able to get here also same things, I is equal to E upon R plus R. Means what? If your concept clear, then easily able to solve the KVLs, able to apply also. Okay na? There are two cases when loop direction similar to the direction of the current in a circuit, then we can use resistor as a consumer of energy and voltage when the current leaving from the cell, positive terminal of the cell, then cell EMF assume delta V is positive. Delta V consider as positive EMF when the first case. Second case, that things able to get negative. Okay, that's all about the KVLs. And next class we'll solve some numerical problem related to KVLs.